All right, tap rules. Page, what page? 11? 9. Page 9, tap rules. We got two primary ones we kind of be using the code book as we go. We'll kind of look at some rules. Matter of fact, the first one is, you read there, overcurrent protection. I done the line that when an overcurrent protection for a conductor is located at the load end instead of its supply. And so what would be an example of that?
Multiple taps for motors.
There you go.
Come down to a disconnect.
Do a disconnect, okay. This means that almost all secondary sides of transformers are, well, let me read the rest of it. Located in instead of the supply side of the conductor, the NEC generally considers that to be a tap. That means that almost all secondary sides of transformer would be considered a tap. Since there's no overcurrent device within the transformer itself, the most frequently used tap rules are the 10-foot and the 25-foot. Because there's not, but windings in a transformer, right? There's not overcurrent protection. You come out 1 volt, come in 1 voltage, come out the other. So, all right. 1.3.1, the 10-foot tap rule. Let's turn to 240, 21B1. 240, 21B1. 240, section 240, 21B1, and it says feeder taps. And it says not over 10 foot. Some of the things as far as highlighting here, I think the thing, smaller conductors may be tapped from larger conductors. Why would we do that?
So you can hook up a receptacle or a switch.
Yeah. Or we can run one feeder over and serve multiple things. What? It does what? Save money, doesn't it? You know? Example we may do in the field a good bit would be feeding a row of overhead doors. Well, each overhead door doesn't need its own circuit. A 1.5 horsepower motor, not pulling enough for a whole circuit, is it? So we can put 3 doors on it. So what would we do? We'd run it over there and we'd tap it. We'd feed 3 overhead doors, wouldn't we? We'd save a little money, wouldn't we? So that's kind of an example, maybe in field. It says, providing that the total length of the tap conductor does not exceed 10 foot. However, there are very specific NEC requirements for each tap rule, including the 10 foot. Now go back to the overhead motors. Overhead doors, that probably won't be in the 25-foot rule. Because we probably wouldn't be able to get down in 10 foot, would we? Okay. So it is important to note that when applying the 10-foot rule, the total length of the tap conductors, I think this is, listen to this, the total length of the tap conductors from their source and supply to the termination points in the overcurrent device cannot exceed, okay, the conductors themselves cannot exceed over 10 foot. The conductors. The NEC requirements for the 10-foot tap rule state that in order for this rule to be applied, the following conditions must be met. I'd like for y'all to read that one at a time. Somebody read the first one. First little bullet point there.
Total length of the tap conductors does not exceed 10 foot.
Right.
3 meters.
Tap conductors not exceed 10 foot. Pretty basic. There's a 10-foot tap rule. Tap conductors not exceed 10 foot. All right, somebody read number 2 there. No, we're not in, we're in our book. We're on page 9 in our book. Second bullet point. My bad.
Second one,
Yeah.
what tap conductors must be rated at no less than the calculated loads to be served or the device to which the tap conductors are connected.
Yeah. Tap conductors must not be rated no less than the calculated load to be served or the device to which the tap conductors are connected. In other words, we're not going to put number 14 wire on a 20-amp receptacle. That's what that's saying. Tap conductor's got to be rated for whatever device. We got a 30-amp plug over there. We're not going to put a number 12 wire on there, are we? So, all right. Bullet point number 3.
The tap conductors cannot extend beyond the switchboard, panel, or control devices that they supply.
Okay. All right. Tap conductors cannot extend beyond the switchboard, panel, or control. That just kind of makes sense, doesn't it? All right. Bullet point number 4,
Is the tap conductors must be enclosed in a raceway.
in a raceway, so they gotta be in a raceway. We'll go back and we'll look at the code here in a minute. And the last thing,
The rating of the line side overburden device supplying the tap conductor shall not exceed 1,000% of the rating of the tap conductors.
yeah, and we're gonna look at that in the code. The rating of the line side overcurrent device supplying the tap conductor shall not exceed 1,000% of the rating of the tap conductor. So now, let's look at that in our code book and kind of get an understanding of what it's saying there. Okay. And it kind of just summed it up a little bit differently in the code book. But the little A, not less than the combined calculated loads on the circuit supplied by the tap conductors. B, not less than the rating of the equipment containing an overcurrent device supplied to the tap conductors. 3, big number 2 here, tap conductors do not extend beyond the switch gear, blah, blah, blah. Number 3, except at the point of connection to the feeder, the tap conductors are enclosed in a raceway. For field installation of tap conductors, leave an enclosure or vault in which the tap is made, the ampacity, and they just kind of word it differently, and I kind of like this actually better than 1,000%, it's the same thing, but it's 1/10. In other words, 1/10 is saying, if I had a 400 amp, how much is 1/10 of 400 amps? What would you do to get 1/10 of 400 amps? Divide by 10, right? And that is what, 40, right? Okay. So what that is saying, let's read that again then. So for field installation, if the tap conductors leave the enclosure or vault in which the tap is made, the ampacity of the tap conductors, or the smaller conductors, is not less than 1/10 of the rating of the overcurrent protecting the. So for that 400 amp, that wire couldn't be less than good for how much? 40 amps. Does that make sense? In other words, we couldn't put a number 10 wire on the tap on 400 amp. But could we put a number 8 THHN? Yeah, because it's good for more, 40 amps, right? So 1/10. Now that's just a 10-foot rule. That's a biggie. And that's kind of where one of the big differences is between 10 and 25-foot rule. And that's just an easy way to remember. 10-foot rule is 1/10. 10 foot, 1/10. 10 foot, 1/10. All right. 25-foot rule has a little bit, about the same rules, but a little bit different. So we go to 240, 21, B2. B2. And let's see, 221, B2. Found that on mine at the top of the page. Perhaps not over 25 foot, and it gives us 3 bullet points, but let's read the bullet points from the book, okay? You may read the first bullet point.
The total length of the tap conductors must not exceed 25 foot.
So, total length, tap conductors, again, key thing, tap conductors, 25%. Now here's where it's going to be different. Read bullet number 2.
The tap conductors must be rated at no less than 1/3 the capacity of the overcurrent device protecting the feeder.
So 10-foot rule is 1/10. All right. 25-foot rule is how much?
1/3.
1/3. So if we had this 400 amp illustration, what would we do to find the maximum? If we divide that by 10 earlier, what would we divide this by? 3, wouldn't we? And we'll see that how much? 400 divided by 3 is how much?
133.
133. And so then if we were to go to our 310, 15, big 16, we would see with size, it couldn't be any smaller than 133 amps. 25-foot rule. Why do you think that makes that? I mean, 10-foot rule, why do you think it can be smaller than 25-foot? Why do you think it's a 10th on 10 and a 1/3 on 25?
Because you got less resistance in the wire, so it won't burn up.
Yeah, I mean, it's just a shorter length, right? It's just not going to heat up as much, shorter length. You get on that, for again, one of the things that affects our voltage drop is what? It's length. Okay. So if we look at our other bullet, so that's the key one. I would mark that one right there. That, to me, that's the important thing. 1/3 of the capacity of the overcurrent device. So this is their overcurrent device on this example. We'll do some examples here in a minute. Bullet point number 3 says what?
The tap conductors must terminate in a single circuit breaker or a single set of fuses that will limit the load to the conductor rating.
Yeah, single circuit breaker, single set of fuses, one disconnect, one circuit breaker. We're not going to do multiple, right? Okay, makes sense, doesn't it? And the last thing,
The tap conductors must be enclosed in a raceway or otherwise suitably protected from physical damage.
so let's just say it's in raceway, right? Now, y'all agree what it's going to be. So that's your 2 rules, 240, 21. The first one is a 10-foot rule. Number 1, number 2 is a 25-foot rule. Okay. All right, let's look at the next thing. If we kind of stay right there in our code book, 220.21b, now we're going to B. Okay, B3 talks about, if the heading of it says tap supplying a transformer, primary plus secondary, not over 25 foot. And if you look there, there's some bullet points there, again, telling us about that. So let's take a look at these bullet points. Somebody read the first one.
That back in the book.
Yeah, we're back in the book. Because I think it's a little easier to understand it in the book.
The primary conductors must have an ampacity that is at least 1/3 the capacity of the overcurrent device protecting the primary conductors.
Yeah, so did anything change? I mean, the only significant word that changed is making sure on the transformer, the rule is saying what the word, what's the key word there? Primary, right? And it's still 1/3. And it's 25 foot. Just make sure you understand the wording there. Number 2, talk about secondary conductors. Read that one.
The secondary conductors must have an opacity not less than the ratio of the primary to the secondary voltage multiplied by 1/3 the size of the overcurrent device protecting the feeder conductors.
Yeah, so still 1/3, isn't it? But the rule talks about secondary conductor. We'll get into what we're doing here in just a minute and show you all what we're saying here. All right, and bullet point number 3 says the total length of the primary, not R, but the primary and the secondary conductors must not exceed 25 foot. I think that's the key. When we're putting it in a field, what do we generally do? How much length are we talking about? How much you use to feed your transformer?
About 15 foot.
Maybe?
Yeah.
At the most, okay? And then your secondary coming out of your transformer is generally what?
Because the panel,
Yeah, it's what? 10 foot, let's say, at the most. Conductors, because we're counting conductors, aren't we? Not the length of the conduit, but the actual conductors, which means we got to count inside of the transformer, we got to count inside of the panels, right? Our total 25 foot. So it gets close. But let's say, like you say, 15 foot primary, 10 foot secondary, does that put us within everything? 25 foot, right? So puts us within it. And so we're good by that rule there. Just as a rule of thumb, just thinking in the field what we generally do. Okay. Number 4, I think, is kind of self-explanatory. It's the same rule in everything that we do. You got to put it in what? For us, we're putting it in what?
Raceway.
Yeah, we're putting it in a raceway. Okay. And the last bullet point, is no different than what we were saying before. The secondary conductors must terminate in a single circuit breaker or set of fuses that limit the load to not more than the conductor ampacity permitted in 310.15. 100-foot tap rule. 240.21b4. Okay? B4 taps over, matter of fact, it says taps over 25 foot. But if you look at number 2, under that, in the code book, the tap conductors are not over 25 foot long, horizontally and not over 100-foot total length. That's where they're getting that from. So there's some rules governing that. Okay. Well, yeah. So use of, yeah, I'm not sure I'm right. Yeah, before. The biggest thing we talked about earlier, we're talking about when are we going to use this tap rule? Where?
Flats in the build, or high bays.
Yeah, high bay. We got over 35 foot. Now, I say generally speaking, when we do a building, that's about our cutoff point. Most of the warehouses we do, somewhere between 30 and 35 foot. Wouldn't you agree?
Yes.
So, you know, so anything over, now we're doing a job in Greensboro, 80-foot ceiling. 80-foot airplane hanger. So there would be a case where, how about out in Michigan, any of those buildings any taller?
Some of them are, but we're not working in them.
You're not working in them?
Yes, but they are.
Nate, you worked in any more than 35 foot, you think? Any instances?
Not ceiling height.
Again, out at Donaldson Center, I've worked in some aircraft hangars out there, definitely over 35 foot. I mean, more than 60 foot range. You ever worked out there in Donaldson Center? A lot of those. And,
My company did like a wire factory once, I think it was South Wire, and they got a big old tower in one of them, so that would have been over.
but would it have been multiple level floors? Or was it just
It was
one?
kind of, it was an open, more.
Was it open?
I think, but
Okay.
I'm not 100% sure.
Okay. All right. So look at the bullet points for a 100-foot rule. Let's read those. Again, we see what? How much? 1/3. Let's just say that. Number 1 talks about 1/3. Okay. The ampacity of the feeder overcurrent protection device. Number 2 is no different than the other rules. It says it's got to terminate in what?
Single breaker.
Single breaker, set of fuses. Okay. Number 3, no different rules. Says it's got to be what?
Protected.
Yeah, protected. Now here's something different we hadn't seen so far. Number 4 says what? The tap conductors must be what?
Not displaced.
Not be spliced. Okay. Number 5 is a little bit different. The tap conductors must be a minimum size of what number size copper?
Number 6.
Number 6. A little bit different there, isn't it? The tap conductors must not penetrate walls, floors, or ceilings. That's the next bullet point. Must not penetrate. Why do you think that? Just think about it. Why do you think that? I want to be able to see, if I'm doing this, I want to be able to see what, I think it's important you see what you're connecting it to. You go through a wall, you go through a floor, whatever, and you got this wire, it's number 6, and you're thinking it's good for what, this number 6, and then in essence, it's tapped somewhere over there that's on a larger wire, right? Whereas if it's all visible, you understand it because you see what? Well, I see that gutter box, or I see that box, or I see where they're tapping it, right? Am I right?
Yes.
So, I mean, that makes sense, doesn't it? The tap of the feeder must be made at least 30 foot above the floor. Okay. The tap of the feeder must be made at least 30 foot above the floor. So there's some different rules with the 100-foot rule, aren't there? All those last 4 bullet points are something different. I've kind of marked those. Particularly like the number 6 wire, got to be at least 30 foot. There's some rules that you would apply. Again, they're not going to use them a lot in the field. There's occasions where this would be used. 240.21b5, if you look here, outside, unlimited length. Outside unlimited length. We see here that there's some bullet points there. First one, no different than what we've been talking about. It's got what? Got to be what? Protected. Conduit. Number 2, no different. Terminating where?
Single breaker.
Yeah, single breaker. Okay. Additional loads must be supplied from the breaker set of fuses. All right. Number 3, the overcurrent device for the conductors is an integral part of the disconnecting means or is located immediately adjacent to the disconnecting means. Kind of makes sense, doesn't it? Number 4, the disconnecting means is installed in a readily, what is readily accessible location? What does readily accessible mean?
You know, cut across or cross facing.
Yeah, and you ain't gotta use what?
So,
You ain't gotta use tools to get to it, which means what? You wouldn't be using what? A ladder. Okay. Ladder, readily accessible. Is a ladder a tool? I think it is. And if it ain't, I don't wanna be without it, right? Okay. Disconnected means is installed at a readily accessible location complying with one of the following: outside of the building or structure, inside the nearest point of entrance of the conductors. In other words, if you're coming in, it's outside and you coming in, and you come through that wall right there, disconnected means better be stuck right there on that wall. You cannot come in, LB in, and go, 2 foot down the wall and put your disconnect. That's not what that says. Why? Because we've got conductors inside the building that are unprotected. Okay. So, come in through the wall, you come in through the wall. I know it's easy to say. Coming through the wall, you're outside, you're coming up, you come through the wall, you better have that disconnected means right there. Okay. Right there's penetrate the wall. That's what that's saying. And it makes sense. Where am I at? We're installed in accordance with 230.6. Now it may tell us, let's look and see what it says, 230.6. Let's turn and see what it says there, 230.6. Now, we get some few exceptions, like it's installed under the slab. Because really, if it's under the slab, we're installed not less than 2 inches beneath the building or structure. Okay. Conductor, let's just read 230.6. Conductors shall be considered outside of the building or other structure under the following conditions. So be outside the building, whether it's installed under not less than 2 inches of concrete. That's outside the building. Is not inside. We're installed within a building or structure in a raceway that is encased in not less than 2 inches of concrete. We're installed in any vault that meets the construction requirements. In other words, if what we're saying then here, if this right here, if this wall, if we needed to hit this wall here, we could bring this in and come up and hit the disconnecting means, couldn't we? Because that's considered outside the building. Number 4, we're installed in conduit and under not less than 18 inches of earth beneath a building or other structure. We're installed with rigid conduit, or IMC, used to accommodate the clearance requirements of 230-24 and routed directly through an eave, but not a wall of a building. So there's some exceptions there where we don't have to do this. So that's a pretty important code right there for getting us around this direct connection when we turn it. Y'all understand that?
yes, sir.
Transformer secondary conductors, 240.21C. 240. What did I say? Yeah, 240.21C. Transformer secondary conductor, back where we were at earlier. Code there is talking about transformer secondary conductors. We look here, code 240.21C3, so we look at 3, C3, which says industrial. C3 will permit secondary conductors from a transformer and lengths up to 25 foot in industrial, and this is the key when you're reading your book here, in industrial installations only when the following conditions are met. Now, what is industrial? Did they actually define that in here? I don't think they did. So, what do we consider industrial? Plant. Okay, not a commercial building, plant work. So, it says, permit secondary conductor from a transformer length up to 25 foot only in industrial when the following conditions are met. And you kind of get into here, it kind of gets you some plant terminology. Because the first bullet point says conditions of maintenance and supervision ensure that only qualified, and I done that person service the system. Now, who's the qualified person in a maintenance, in an industrial facility?
Maintenance man.
The maintenance guy, most of the time, isn't it? So, because they have somebody, in a commercial building, you don't have somebody designated for maintenance. But usually in an industrial plant, you've got what? You've got a facilities guy, you've got a guy's maintenance guy. And so that's what they're talking about there. You got qualified. In other words, he understands electricity, he can work on it, he's not the janitor. You know, so, all right, who can just show you where the panel's at. So he's actually qualified, he actually has tools, he can do it. Bullet point number 2, the ampacity of the secondary conductors is not less than the secondary current rating of the transformer. The sum of the ratings of the overcurrent does not exceed, in other words, just can't exceed it. The ampacity of the conductors can't exceed the overcurrent protection. The overcurrent devices are grouped. Why do you think that's important in a plant? We want them right there together, don't we? We don't want here, one over there. Okay, not knowing what it is. I mean, this guy, when he put it in, might know, but he might not be the maintenance guy 2 years from now. You know, somebody else will be. Number 4, the secondary conductors are protected from physical damage. In other words, we're going to put it in what? Put it in conduit. Yeah. Now, C6, if we look here in the code book, C6, since secondary conductors over 25 foot. Lengths up to C6 will permit conductors from a transformer in lengths up to 25 foot when these conditions are met. The ratio of the primary and secondary voltage is multiplied by 1/3. Sound familiar? The secondary conductors terminate in a single circuit breaker. Sound familiar? And the conductors are protected from physical damage. All right. So look at a couple of examples here they got in the book. So using the 10-foot tap rule, what size THWN copper conductors required for a 40 horsepower, 460 volt, 3-phase motor load tap from a 400 amp feeder when all terminations are marked as suitable for 75 degree. All right. First thing we got to do, we got to find out how much. Where do we go? What is our code book? Where are motors? Section what? 430. 430. 3-phase motors is 430.250. Table 430.250. Table 430.250. Let's turn to there. .250 of 250 3-phase motors. Here's the table. 430, 250. What was the horsepower? 40 horsepower. 460 volts. And somebody tell me what the amps would be. $52. But our motor's what? Our motor's always what duty? Continuous duty unless it's listed otherwise. So we got to take that 52 and multiply it times 1.25. And that gives us how much?
65 amps.
65 amps. All right, let's hold on to that. All right. Now let's go to 310.15b16. And it mentioned 75 degrees, didn't it? So we know 65 amps. If we look at 310.15b16, 75 degree column, I want y'all to tell me what size wire we'd use.
Number 6.
Number 6. So that's good for 65 amps, isn't it?
Yes, sir.
All right. Will that work with our tap rule? Okay. We got a 10-foot tap rule. What does our 10-foot tap rule say? What size? We had a 400 amp feeder. What it said. So 10-foot tap rule is how much? One what?
110.
1/10. So 40 amps. So can we use that? Yeah, because it meets our minimum requirement. Okay, so we can use that, can we? Make sense? Not too bad. Number two, example number two, what size THWN conductors are required for a 25, so this 25 foot, note that, supplying a load of 100 amps from a feeder protected by a 600 amp overcurrent device. Okay, and and it tells us here, so if it applies a 25 foot rule, the tap conductors must be rated at least of what? Let's figure that out first. What? A third, right? Which is, so for 200 amps, got to be rated at least that. So it asks us to question what size, okay? Conductors must be rated at least 200 amps, even though supply load is 100 amps, right? It says supply load 100 amps. So we got to go to 31015B16. We got to find a wire that's good for at least how much amps?
200,
Yeah. And we're going to go to what column?
75.
75-3 column. And we're going to find that we're really, even though it's a 100 amp load, we have to use what size wire?
3 ohm.
3 ohm. Okay. And that's 75-3 column. 3 ohm. Because we could not, you understand why we did that? Because we can't use anything less than that. Even though it says it's a 100 amp load. We know one of the rules says you cannot use anything less than a third of what this rated overcurrent device is on a 25 foot rule. Now, if this had been a 10 foot rule, what would it be?
60.
Yeah, 60. Okay. Then we'd have been okay. Then we would have went to 100 amp. But it's 25 foot rule. Okay. All right, so that's tap rules. Last couple of sections tonight, and we'll be done. Okay. Demand factors. We talked about demand factors. Let's turn to 220 in our code book. Section 220, we'll start with 42, 220, 42. The first thing we see there is a lighting load demand factor. Lighting load demand factors. And what that does, it tells us like in a dwelling. If you read that, it says like in a dwelling, the first 3,000 is 100%. From 3,001 to 120 VA, you do 35%. So there's a substantial drop off. 3,000 VA is not much. Matter of fact, 3,000 VA is only a couple of small appliances loads because each small appliance loads 1,500. So anything over that, we start to really deduct, because in a house, what's going to happen? You going to turn everything on at once?
No.
No. Your kids might, but you're not. You know, if you got kids, they will. They'll leave every light on the house on, and they'll turn everything on, and you go outside and see the little wheel spinning around and around. Yeah, they go outside and play, leave everything on. All the TVs are on. You know, if they could, they'd turn the heat and the air conditioning on properly. That's right. 220.44 just talks about receptacle loads other than dwelling. And you see what the rule is there. 220.54, we look there's clothes dryers. The biggest thing I want you to know about clothes dryers, first of all, if you got more than 4 clothes dryers in your house, you got a big family. Okay. But this would apply when we have apartments. But 1 to 4 is 100%. You get over 4 to 5, then you start to derate. This is because in every matter of fact, in every apartment you have what? You have a dryer connection, right? Pretty much. Hopefully you do, unless you really live in the slums. Okay, you got a dryer connection, and because of that, that rule may come into play when you got multiple dryers on one service. 220.55, we got a table there. 220.55, sorry. 220.55 is electric cooking in dwelling and household cooking appliance used in instructional programs, 250-55. 220-56 talks about other kitchen equipment other than dwelling units. You see there's some factors there. 220-82, just some optional ways of doing stuff as far as dwelling. You know, there's standard ways of calculating loads, and there's optional ways. Optional way is the easier way. It's only like a 2-step process. A regular standard dwelling calculation is like 7 steps. Optional is only 2, if y'all remember that from the other class. It was much easier. But you can't do optional unless, as far as taking the test, unless they tell you can do optional. And that's what the rest of those right there deal with, optional method. 220-102, which we probably don't get into around here too much. If you turn over to 220-102, it talks about farm loads. And 220-102 and 103 talk about farm loads. All right, let's look at a couple of examples here. Example. The total general purpose receptacle load in an office building is 26,800 VA. What is VA? Okay. Let's go back to our lighting load, which was 220-42. 220-42. $220-44, I'm sorry. Because we're not in a dwelling, are we? My bad, I went the wrong place. We're not in a dwelling. So it says receptacle loads calculated in accordance with 220-14 H&I shall be permitted to be made to subject to demand factors given in 220-42 or 220-44. Now 220-42, we don't see anything. Look at 220-44. It says demand factors for dwelling receptacle loads, portion receptacles to which demand factor applies. The first 10 kVA is what? 100%. Okay. And then the rest is what?
50.
All right. So the first 10 kVA, we're going to subtract. We got 26,800 times 10 is how much? 16,800. What are we going to do 16,800 times?
0.5.
Yeah. Times 0.5, which is how much? 8,400? We got 8,400. Now what are we going to add to that 8,400? What we took out? 10,000. So we really see then that the total connected load for this example is 18,400 volt amps. Okay. Or if you really wanted to get down, let's say this is the 12240. We'd find out how many amps it is by 18,400 divided by what? 240, wouldn't we? And how many amps would that be? Just to do it, just curiosity. $76. All right. 1.4.1 is talking about neutral conductors. Well, there's a couple things as far as, if we're looking at our code book, 220, let's look at 22061. There's actually a couple of reductions that you can actually do for neutral conduction. Basic calculation is A. B is permitted reductions. You can do, let's look at that. A service or feeder supplying the following loads shall be permitted additional demand factor 70%. Okay, you see that there? A, household electric ranges can be reduced to 70%. B, and well, let me just read on there. Household electric ranges, wall-mounted ovens, counter-mounted cooking, electric dryers, you can take 70%. So that's the two main things, ranges and dryers. We won't get into B right now because I don't think we'll need that. So I mean number 2, number 1. So if we look here, neutral conductor electrical system generally carries only what? What is it? What does a neutral carry? Without reading it, what does a neutral carry? Unbalanced. You know, unbalanced load, doesn't it? the phase conductors or the hot conductors. For example, in a single phase feeder circuit, one phase conductor carrying 50 amps, the other one carrying 40, the neutral is going to carry what? It's going to carry 10. Since the neutral in many cases will not be required to carry as much as the phase conductor, NEC allows to apply a demand factor. A demand factor always means we're probably going to be able to reduce what we're doing. That's what a demand factor is. Also, 310.15b5 allows the exclusion of a neutral conductor carrying only unbalanced current when determining or adjusting the factor for 3 or more conductors in a conduit. A couple other things, and we'll wrap up and do these review questions. We'll call it a night. Service conductor considerations. Y'all can read that there. It's just got some definitions there that you need to see. The last thing I want you to see is lighting loads. 220.12. If you turn to code book 220.12, there's actually a table. 220.12. And it gets into lighting loads. It's, as a matter of fact, the headings, general lighting loads for occupancy. And for example, like in a dwelling, it's how many VAs per square foot for a dwelling. Table 220.12, the big table, 220.12. 220.12, what is the VA for a dwelling? How many VAs per square foot for a dwelling? 3. Yeah, it's 3. In other words, then if I had, well, all that's saying, if I had a dwelling, what? That's my house, right? James, you live in a mansion. So James has a 20,000 square foot house. Y'all hear that on tape? He has a 20,000 square foot house. James lives in a mansion.
Been there in 6th Street.
Yeah. So Ronnie lives in a 1,500 square foot house. Y'all hear that? Y'all hear that? 1,500. James is in the 20,000. Guess who makes more money? Okay. But what we're going to do with that? So 20,000 square foot. That's what it says. So we're going to dwelling. The lighting load for that house would be what?
60,000.
60,000. James uses a lot of lights. 1,500 square foot house. Ronnie's poor, but he doesn't cut on a whole lot of lights, so it's only 4,500. Big difference, isn't it? Really? Yeah. But that's what they say the average is. Okay. All right. Yeah, and that's for a house. And if you look, you know, like we don't do dwellings, but we do like a restaurant. Look at restaurant. What is a restaurant per square foot? A restaurant?
Restaurant is 2.
2.
Sorry.
Now look at something that we really do a lot of. Just a storage warehouse, you really get, how much just a storage warehouse? A quarter. Yeah. Pretty small, isn't it? So we got a 200,000 square foot warehouse. What are we going to multiply it by? What is a quarter? 0.25, isn't it? So 200,000 times 0.25, what is their lighting load? 200,000 square foot building. How much are a lighting load, Nate?
50,000.
50,000? Okay. Less than James's house. Let's look at our 4 things we'll call it a night. Number 1. For NEC 310.15b3a, the ampacity of 15 current carrying conductors must be adjusted by what? 310.15b3a, the table in your book. We've got 15 current carrying conductors. What do we have to adjust by? 310, 15, B3A,
50%.
50%, C. Okay. What is the ampacity of a single-phase resistance load with a nameplate rating of 38 kW, 240 volt? What are we going to do? We got to take what? 38.4 and turn it into what?
38,400.
38,400?
Should be 160 amps.
160 amps, which is A. Because we divided 38,400 divided by what?
240.
240, 160 amps. Number 3, a high bay manufacturing building with a wall height of 50 foot has a maximum horizontal tap length of what? High bay with 50 foot has a maximum horizontal tap length of what? Let's turn to 1.3.4. 25, yeah, very good, 25.
Because it's horizontal.
Yeah, because it's horizontal. Horizontal is what we're going across. Because 50 foot, we know, we're already doing what?
You're doing 100 foot.
Yeah, okay. So 25 foot as far as we can go across, isn't it? The total general purpose receptacle load in an office building, 16,400 VA. The demand load is what? Let's go back to our table that we were at just a minute ago. What did we do when we did an office building? We took what? We took 10,000 out, right? That was 100%. So we take the difference, which is 16,000. Y'all help me out. 16,400 less 10,000 is how much?
6,400.
And how much percentage are we going to take of that? Half of it, or multiply times 0.5. We're going to get what? 3,200. What are we going to do with that 3,200? Add it back to 10,000, and we get 13,200, and hopefully that's one of our answers. C. All right, next week. For those that are watching it, Mark and Barry, we got Module 1, Section 2. Module 1, Section 2. Okay. That's for homework. For homework, you are reading in your book. Not much, not a whole lot. You're actually starting on page 14, Section 2, 2.00, and you're reading just through on page 17 up to 2.2.0. So you're only reading really 3 pages. We'll cover those 3 pages next week. 3 pages. That's all we'll cover next week. And that'll be session number 3. Do your homework. We won't do that next week. We'll actually wait till we'll complete that. We'll do that together in 2 weeks. But that's section 2. You can go ahead and start working on that. Okay? That's section 2. That actually won't be due till the following week. But you can start working on that. Okay? All right, we good? All right, guys. We have filmed our first session. Oh, attendance sheet. Here, y'all need to do this.
Wait on
Do those.
That might be a bigger number than that.
Yeah,
Looks bigger.
true. What's today's date? 24th, I think.